Okay, so you know that my claim is the whole world is biological, and there's just gigantic creatures. I can't explain it, and that's the case. They were all written about in the ancient texts. It appears to be true. These are the tendon anchor balls. You have fibers, and you have literally millions of fibers and balls virtually everywhere in your body. And they are so tiny, nobody ever sees them. But they are in there, attached to these little tiny fibers. Now, in these giant creatures, they are gigantic. Okay, we're going to be talking about Bennu and the samples that they brought back, and I think I can explain them and show you what they are right now. Now, to get get an idea of perspective, people, you know, millimeters, micrometers, and micron, all that stuff, they don't really understand to see the physical distance. Now, I got a caliper here. This is 1 millimeter, all right? That little block is, well, this is 1 millimeter. That block is like much smaller than a millimeter, if this distance is 1 millimeter. All right, and we're homing in on this block, and that's this block over here. You see that little thing? That's that little thing. So you got to sort of try to understand what they're showing you. This shows, oh boy. All right, let's start this off by trying to understand what they brought back from Bennu. Now that's an asteroid that's in space. They saw it, they landed on there with a lander, grabbed a bunch of stuff, brought it back. It landed back here in September last year, and they've been analyzing it ever since. And I said what I thought it was before they came back with it. When they landed there, I said, I know what the thing is, and I do. This is the piece they're showing, and the white is what they call phosphates. We'll talk about that in a minute. The rest is clay. So the phosphates are shown highlighted with a certain light, and here they're just shown as the clay. Now, this little block has been expanded here. You see that little chunk coming off it? That's this chunk here. So now we're going down again, a smaller block, and that's this block. How big are we talking about? What's in 1 millimeter, and what's all that stuff about? Let me give you the distances here. First of all, metric distances go this way right here. A micrometer, a micrometer, this is a micrometer. A micrometer, or micron, is a metric unit measurement for the length that is equal to 1/1,000,000th of a meter. That's the little looking thing. Or is it also 1,000th of a millimeter? Well, how big is a millimeter? The symbol for micrometer is that little Now, that right there, my friends, that distance coming out the top, that little bump, is 1 millimeter. And I know that because that's what it's set at right there on a millimeter range, and that's 1.0. So that little tip, that's how much 1 millimeter is, that length. All right, so hopefully you understand the perspective here. This is 1 millimeter, which is 1,000th of a meter. This is 100 microns, which is 100 millionths of a meter, and this is 50, which is half of that. So we're getting right down to those little blocks, and those blocks, I understand exactly what they are, and you will in a moment too. Okay, you see those little blocky looking things there? It's torn up here and torn up there. That's an injury. And what is an injury to? Heart muscle. That's heart muscle. And that's virtually what you see came back from Bennu. And of course, this is from a electron microscope. Okay, my outstanding friends, I got off track, but I think it's going to be fun. I was going to starting with the moss and showing how everything is just coated with moss. Red blood and moss just love each other. And I was going to be going into this because I found this on my property the other day, and I'm going to excavate it out. At first I looked, I said, it's just a bone form and some from a giant creature. But then I looked and I started looking at it, and this piece right here almost looks like it could have been a nose coming down from here and it's broken off. And something's going on over here, I'm going to go out and excavate it. But if you had another eyeball right there, that's possible. I don't know. I'm going to go out with my pickaxe and all kind of stuff, and we're going to see if we can dig that up, or is it just locked into something out there? Because I have so much stuff. It's just too much. What that is, I don't know. But I was started off by saying everything there is. Moss has to be inside of red blood. It has to be part of red blood somehow. Look at this. These are all tendon balls. Let me just show you something real quick, and then I'm going to go on to the other thing. These are all tendon entices, and there's thousands and thousands of them in every single bone, and every single place a tendon locks in, thousands and thousands and thousands of them. These creatures were so gigantic that this is thawing out, and these are tendon balls. You see them up here? You see them? Everywhere, the whole thing, 100% of, and every one of them is coated with 100% green around it moss. That's no way that it could have spread. It's got to be locked into the blood. It has to be. Somehow it has to be, and that's the coating, which is the membrane that surrounds these balls. So this, and I've looked at a ton of stuff, and they all show that same characteristic. And even like this thing here, I don't even know what the hell it is. It's a big green monster over in Czech Republic, and this stuff is real. This is real, and the reason it's green is it was a flea or something. It was still loaded with blood. As far as I'm concerned, I'm pretty sure of that. Now we're going to go into the sample from Bennu. This is starting to age, and it needs to be taken care of because it's quite obvious what it is. So let's get into the Bennu deal right now, and this is it right here. That's Bennu. That's a heart. That's psyche. All right, now I'm going to show you this whole thing, but Bennu is a heart, and what they brought back is a zero question right now. It's zero. Okay, my friends, let's read this carefully. They went to this Bennu and they grabbed that sample, they came back with it, and they said, wow, phosphate surprise. They never expected phosphates. So they started looking into this, and they said the analysis of the Bennu sample unveiled intriguing insights into the asteroid's composition. Now, dominated by clay minerals, which is flesh, basically. Clay is nothing more than flesh, particularly serpentine. We'll look at that in a minute. The sample mirrors the type of rock found at mid-ocean ridges on Earth. So they say, boy, this is very similar to Earth, where material from the mantle beneath Earth's crust encounters water. Well, no. This is a membrane. Now, I'm going to tell you exactly why. I can make that statement, make it stick. This interaction doesn't just result in clay formation. Clay is flesh. It also gives rise to a variety of minerals like carbonates, iron oxides, which is blood, iron sulfides, which is blood in transition. Iron oxides is blood, oxygenated, deoxygenated. They're all iron. And that's what blood is iron. The most unexpected discovery is the presence of water-soluble phosphates. You see these white things? Those are the phosphates. I'm going to show you that in a second. These compounds are components of biochemistry for all known life on Earth. You know why? They're membranes. Everything there is has membranes. Phosphates are membranes. And they are coating muscle. And these are the muscles right here. These are the muscle sarcomeres. I show this in great detail. You see this? The sarcomeres are laying right on top of a membrane. That's the membrane. This little chunk right here, you see it? They highlighted the white so you could see it with some kind of lighting. And I'll show you these in great detail. I have some here in my shop. And then there's more clay on top. So there's muscle on here, then there's a membrane, then there's muscle on the top. Now, here's the muscle. Whoops. There's the muscle, and here it is close up right here. Real close. I mean very close. All right, so this is the tiny fraction of asteroid Bennu returned from this mission shown in microscope images. All right, right, now the top left shows a dark Bennu particle about 1 millimeter long, which is that tiny little thing I showed you, with an outer crust of bright phosphate. That's the membrane. The other 3 panels show progressively zoomed in views. All right, now they say a fragment of the particle split off along a bright vein containing phosphate. That is or everybody's membranes. All membranes are made of phospholipids, phosphates, phospholipids. And this is all scanning microscope stuff. And this is from what they brought back. And the finding of magnesium, sodium, phosphates, all of this stuff, is all they got to do is test it. It's blood. This came out of a heart. That came out of a heart. So I would say it's time to look at this for what the mission was designed to do, is to figure out what it is, and it is a heart. All right, you ready for this? All membranes contain phosphates. This was their surprising finding. Now, again, there's the clay, then the phosphate layer, which is membrane, then another layer of clay, and those are muscles, showing that. Now, you see these right here? Let's zoom in close on that. You see these little fibers? It's kind of foggy looking, but they're little fibers of white flakes, which is part of the fabric of fascia. Fascia has to, especially in a heart, it's going like this all the time. These have to stretch and pull, and that's part of the fabric of the heart. All right, and you got a lot of layering in that heart, because it's continuously doing this all day long, just as your lungs do. This is a lung. It's been DNA tested. It's been CAT scanned. It's 100% Homo sapien mitochondrial DNA, which is modern human. Now, this is the same fabric as this. I will show you, because a pleura on a lung has to go roop, 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 just like a heart. Now, this died in the flood because it's flat as a pancake. This is from the mud fossils. I understand this stuff very, very well. We're going to look at this in a microscope, and I'm going to show you these fibers, and I'll show you the fibers on here. They're ubiquitous. They're in every living thing. They say it. It's in everything. All life on Earth has them. Even plants, animals, plants, doesn't matter. You have to have membranes. Okay, let me explain something to you. These are muscle sarcomeres, identical to the sarcomeres that are in the heart. However, the heart has a lot of these tissue layers in them that are the phosphates, where they found the phosphates. This is blood servicing muscle. Muscle needs a lot of blood, and the heart does too. The heart uses a ton of blood to pump. It pumps a ton of blood, but it uses a ton of blood to pump it. Now, here in a muscle, it just contracts or so forth. It's not like, it's a different sort of mechanism. In the heart, there's just so much fiber that you need. The muscles are not heavily invested in that much fiber. Where the tendons come in, yes, a lot of fiber, but then you go to the muscle that just squeezes. Now, let's take a look at what heart sarcomeres look like. A little bit different. All right, watch this. As I showed you before, this is the membrane. That's just another piece of muscle that's sitting on top of the membrane. Tons of membranes. Now, the heart and the lungs are basically the same. They have to squish all day long. So we're looking at the one right here in the microscope, which is a lung, and there's no question it's a lung. And here it is up here. There's the same fibers. Those are the same fibers. You see them, the white fibers there? Those are the fabric. You can stretch like this and pull and so forth. Otherwise, your lungs would just fail. And I mean, I have so much of this stuff. It's just amazing. Anyway, that's the fibers. Now, there's the fibers right there. The same fibers. Same fibers. And you're going to have them all throughout the heart, because the heart has to do all this all day long, or you die. Okay, I guess I'm going to wrap it up for the heart here. This is Bennu, Bennu right here. It's just what it is. And these are the valves. The top breaks off right here. And a lot of the hearts that I have found, there's a weak spot right here, but it's glued. The heart can sort of move around in that glue, but when it dries out, it just breaks off, basically. Now, so it's gone. And the same thing here. But right there is where you have your tendon. And then the tendon locks into the muscle. So the tendon's coming down, locking into the muscle. These are all tubes coming out of here. These aren't craters. I'll show you in a better shot. And this is psyche. You see the architecture of that compared to this? There's no difference. None. This one here, cooked up though, hot enough to where the metals, because blood is literally almost all metal. You know, plasma, water, all that stuff, yes. But the particulates in there are almost all metals. All the transition metals, all the way up to uranium is in your blood, and it's got to be there. It has a job to do. Now, that's the same thing. It's the same. It's the same as a heart. And we can see this very, very clearly. Let me just show you something. And the tube's coming out. And now we have in our hands the samples, the sarcomeres, the phosphates, which is the membranes. We have the actual blood. That can be tested very simply, very simply. Now, we all know the different oxides of blood are the red, the orange looking stuff, which is in the middle, and then the black, which is the totally devoid. You see this? That right there, my friends, is not a crater. That's a tube coming out. All of these spots, almost all of them, there's going to be some maybe that got hit by craters, but not too, by impacts, but not too many. Almost all of these are little blood vessels that are in the heart has just literally thousands and thousands of them. This is another tube coming out. That's not a crater, it's a tube. They're all over the place, basically, because that's what happens. Your heart has a ton of little tubing in it, squirting this and that, and it has all of its own tubing that surrounds it. Now, this is obviously eroded down to where the blood vessels have cooked and popped out. These are popped out. That is not an impact. These are popped out. And that's because they get cooked from the sun and they pop right out of their little vessels. So what did they discover about Bennu? Well, the phosphate surprise, I think we went over that, and I showed you the sarcomeres and the membranes and all that stuff. Now, from a young solar system, what does that mean? Despite possible history of interaction with water, Bennu remains a chemically primitive asteroid with proportions closely resembling those of the Sun, which I found extremely interesting. The Sun has the same chemistry, they're saying. Now, that's very interesting to me. The sample we returned is the largest reservoir unaltered asteroid material on Earth right now. This composition offers a glimpse into the early days of our solar system. Over 4.5 billion years ago, these rocks have retained their original state, having neither melted nor resolidified since their inception, affirming their ancient origins. Not ancient, as they say now. So now you go at hints of life's building blocks. The team has confirmed the asteroid is rich in carbon and nitrogen. That's us. These elements are crucial in understanding the environment where Bennu materials originated in a body of some gigantic creature, and the chemical processes transformed simple elements into sarcomeres and blood and tissue, which are the complex molecules potentially laying the groundwork for life on Earth. No, these were giant creatures. These findings underscore the importance of collecting, studying material from asteroids like Bennu. I have a meteorite here that's a lung, especially low-density material that would typically burn up upon entering Earth's atmosphere. Well, if it's small enough, like this lung, you see that? It's a lung, and it's an iron lung, but it's not big enough to burn up. The resistance coming through the atmosphere was enough to cook it. but not just cook it to nothing. And it has the spur lock on it, which is the latch that holds it into place in the body. It has all of, and it actually still has, I believe, some, well, I know it has catalase in it. I mean, yeah, catalase, because I did the hydrogen peroxide test and it bubbled up here and there. Now, it's cooked up a little bit, but not all that bad. It's very magnetic though. Now, and you got to get at least 2,700 degrees in that area before you start getting iron, which is blood, which is hematite, to turn into iron. So it had to be hot. And you don't get it hot like that on Earth just laying around. No. Because the Iron Age had to come only after there was enough oxygen in the atmosphere to create iron. You have to have a real lot of oxygen. That's why they made a bellows. Anyway, so what's next for all of this hints of life's building blocks? Yes, this is everywhere. 100% of life has phosphates and phospholipid membranes. 100%. Plants, animals, everything. So what's next? Dozens more labs in the United States around the world receive portions of the Bennu sample from this Johnson Space Center in the coming months. Many more scientific papers describe the analysis. Well, in the next few years, well, let's see what it is. What is the chemistry? I want to know the chemistry. They can do that very, very quickly. Bennu samples are tantalizing, beautiful extraterrestrial rocks. Well, yes. So anyway, they go about how they went up there, launched, 8 years ago. But we have them here on Earth right now, and I know exactly what they are. I just showed you what they are. So I think it's time to take it for what it is and at least give us the chemical analysis, because I know the chemical analysis of blood. And here it is right here. If they want to know what it is, here's what it is, my friends. This is what's in whole blood. All of these different metals. You see that? These are all metals. Metals, metal, 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 metal. All right. This is plasma. Same thing. All metals, different amounts, different isotopic values, and so forth. And this is serum, I think. Well, I've got it all. Everything you need to know is right here. In this one paper about what's in blood. And I'm telling you right now, everything they took down was blood. It's blood and tissue. And the phosphates are the membranes. What it is what it is. See that? As the flesh sort of eroded away to a degree, the things, I don't know how long it's been out there, but these explode because they get cooked off inside. And if you look at COM 67P, it's literally gassing off when it hits the correct spot coming around the sun. It squirts out barbecue smoke. All the astronauts say when they come in from the spacewalk, they take their suit off and it smells like steak. All of them. That's because this is what's cooking out there. It's biology. It's hearts and lungs and all the rest that goes with biology. It's just what it is, my friends. Now, I was going to go into this moss and stuff. Look at that. Isn't that fabulous? I have a lot of information on moss and something I discovered in my yard, actually. Where'd it go? Somewhere around here. There it is right there. I want to go out and look at this again. Here's how I get started. I think I did mention this in the beginning, that the moss grows in where there's blood. Now, at first I just thought, it's no big deal, it's just a bone form. Then I looked at this, and that almost looks like it's broken off of a nose, where the nose would have maybe stuck out like that. And then this almost looks like there's another possible eye socket right there. You see that? That looks to me like it could have been a nose. I don't know. And it would have maybe stuck off like this or lumped over, or I don't know. And then if there was another eyeball right over here somewhere, something like that, that would finish it off. I don't know. I'm going to go out and dig it up and we're going to find out. So that, and I got some other things to show you on my property that, I got a source that I can go on forever. Just look at this. These are all, I got so much stuff here. I could do this for the rest of my life, and I probably will, because I don't know how long that's going to last. And there's just, I know there's a bunch of no-toes in here right now. There's lungs, there's hearts, there's everything. This is not just nothing. These are all rocks or something. And look at this thing. We're going to go into all that stuff. But for now, I think we should be understanding what we're looking at. These heart sarcomeres. That, well, this is not heart sarcomeres, but the sarcomeres are the same. But in the heart, you have a lot more connective tissue running in amongst the sarcomeres because you got a lot more. It's a heavy-duty piece of construction, and you don't want that thing failing. All right. Anyway, I love you all. We'll talk again.